A discussion with General Electric (GE) Aerospace, which started in 2012 over transferring 58% technology to India for manufacturing jet engines, eventually took shape Thursday, with the former agreeing to transfer 80% of the technology instead after hectic negotiations in the last few years, a top defense official said Friday. On Thursday, GE Aerospace signed a Memorandum of Understanding with Hindustan Aeronautics Limited (HAL) on Thursday to produce fighter jet engines for the Indian Air Force. The announcement of the pact came during Prime Minister Narendra Modi's state visit to the U.S. The final deal is expected to be signed soon after approval from the U.S. Congress and finalization of commercial terms. After 2014, there were ambitions of getting a higher percentage of technology transfer. Complete technology transfer has been agreed to on certain parameters, which was not agreed to in 2012, the official said. This shows the emergence of India as a trusted partner for several nations, the official said, adding that Defence Minister Rajnath Singh had played a major role in fueling the signing of the agreements. As per the official, the 12 key technologies offered included special coatings for corrosion and thermal barrier for hot end, machining and coating for single crystal for turbine blades, machining and coating of nozzle guide vanes and other hot end parts, and blisk machining. The technologies offered also include machining of powder metallurgy discs, machining of thin-walled titanium casing, friction, inertia welding for fan and afterburner, polymer matrix composites for bypass duct, machining and coating of ceramic matrix composites for nozzle guide vanes and flaps, laser drilling technology for combustor and bottle boring of shafts. Defense officials said that out of these, GE has offered complete transfer of technology for special coatings for corrosion and thermal barrier for hot end, laser drilling technology for combustor, bottle boring of shafts, blisk machining of thin-walled titanium casing, friction, inertia welding for fan and afterburner and for polymer matrix composites for bypass duct. Only limited technology transfer was offered earlier for special coatings for corrosion and thermal barrier for hot end, and there was no transfer of technology offered under laser drilling technology for combustor. Similarly, earlier when GE was to transfer 58% technology, only machining was offered for single crystal for turbine blades, machining and coating of nozzle guide vanes and other hot end parts, but now coatings have been added as well. No technology transfer was offered earlier for laser drilling technology for combustor. But under the 80% technology transfer, machining and coating has been added. Many of these technologies are critical to help retain the structure of turbine blades in high heat when a combat jet takes flight. Only a handful of countries such as the US, Russia, the UK and France have been able to master these specialized technologies needed to manufacture an engine that can power a combat aircraft. The F-414 engines will power the IAF's light combat aircraft Mk2 jets. GE Aerospace said in a statement on Thursday that the agreement with HAL on jet engines will advance its earlier commitment to build 99 engines for the IAF as part of the LCA Mk2 program. The defense official quoted above said the manufacturing of the jet engine should start taking place within the next 3 years of signing the deal, and they will be timed according to the orders placed for the LCA Mk2 and the testing of the aircraft prototype. This will also likely take the indigenous content in the aircraft to 75%, the official said. Asked if the same GE engine would power India's futuristic Advanced Medium Combat Aircraft (AMCA) fighters, officials said they would require an engine of a higher thrust of 110 kilonewtons. Aside from GE, India has been talking to other global jet engine makers for technology transfer such as Safran SAE of France and Rolls-Royce of the UK for the AMCA. The decision on which engine would power the AMCA would be taken later, after the specifications of the aircraft are finalized. Officials said the deal would help the Indian aerospace industry by providing access to new generation technology, new material and processes, increased indigenous content in the aircraft and lesser turnaround time for their repair and maintenance. The engine will also enable the aircraft to carry increased payload and fuel, advanced sensors, larger display glass cockpit, a range of indigenous weapons, wingtip missiles, and will have a higher thrust-to-weight ratio. A joint statement issued by India and the US on Friday stated that PM Modi and President Biden have hailed the landmark signing of an MOU between GE and HAL for the manufacture of GE F414 jet engines in India, for LCA Mk2. This trailblazing initiative to manufacture F414 engines in India will enable greater transfer of US jet engine technology than ever before. The leaders committed their governments to working collaboratively and expeditiously to support the advancement of this unprecedented co-production and technology transfer proposal, it said.